Hello good day viewers. In this tutorial, I'm going to show you how you can solve this exponential equation without substitution. Alright, let's get started. The equation is e to the 4x minus e to the 3x minus 4e to the 2x minus e to the x plus 1 equal to 0. And we are looking for the value or values of x that can satisfy this equation. You should know that e to the power of x is forever greater than 0. If this is the case, we can divide every single term by e to the 2x. So let's do that. I want us to divide everything here by e to the 2x. It's allowed since we are dividing every single term. If you take the first term, which is e to the 4x, you divide it by e to the 2x, you're going to obtain e to the what? 2x minus the second one, e to the 3x divided by e to the 2x is e to the x minus 4 e to the 2x divided by e to the 2x is 1. You go to the next one, minus e to the x divided by e to the 2x is 1 divided by e to the x. Then plus 1 divided by e to the 2x. If you divide 0 by e to the 2x, you're still going to get 0. Now, I want us to connect these two together, this, and also these two together. So let's do that. We have e to the 2x plus 1 divided by e to the 2x. Then we have this one and this one together. Let me factor out the negative sign. Inside we have e to the x plus 1 divided by e to the x. Then remember we have minus 4. Minus 4, the whole of this equal to 0. You should know that these first two terms can be written as e to the x plus 1 divided by e to the x all squared minus 2. I will show you how. Then we have minus e to the x plus 1 divided by e to the x minus 4 equal to 0. But let me show you how I got these two terms. If you have e to the x plus 1 divided by e to the x, and you decide to square this, this will be equal to the first term squared. E to the x squared will be e to the 2x. Plus the second term squared is 1 divided by e to the 2x. Then plus 2 multiplied by the first term multiplied by the second term. First times second term will give us 1, and 1 times 2 is still 2. So what if we decide to make the whole of this the subject? All you have to do is to take these two to the left hand side, right? So you have e to the x plus 1 divided by e to the x all squared minus 2 equal to e to the 2x plus 1 divided by e to the 2x. Therefore, this e to the 2x plus 1 divided by e to the 2x can be written as e to the x plus 1 divided by e to the x all squared minus 2. All right, let's continue. So from here, we may decide to take this negative 2 and connect it with this negative 4, and that will give us negative 6, right? So we have e to the x plus 1 divided by e to the x all squared minus e to the x plus 1 divided by e to the x minus 6. The whole of this equal to 0. If you observe, this is just a quadratic equation in terms of e to the x plus 1 divided by e to the x. Because look at them, they're exactly the same, right? It's just like saying y squared minus y minus 6 equal to 0. And it can be factorized because we can think of two numbers, which when we multiply them together, we get negative 6. And when we add them together, we get the coefficient of the middle term, which is negative 1. And the numbers are positive 2 and negative 3, right? Therefore, you can factorize it as e to the x plus 1 divided by e to the x plus 2, right? then multiply by e to the x plus 1 divided by e to the x, then minus 3, the whole of this equal to 0. Let us set each factor to be equal to 0. E to the x plus 1 divided by e to the x plus 2 equal to 0, or the other one, e to the x plus 1 divided by e to the x minus 3 equal to 0. Let us rearrange them. We have e to the x plus 1 divided by e to the x equal to negative 2, or e to the x plus 1 divided by e to the x equal to positive 3 if negative 3 crosses over. One thing you should observe, both e to the x and 1 divided by e to the x are positive numbers. Therefore, there is no way you can get this negative 2, and hence we are going to disqualify this solution and consider this one. Therefore, our main equation that we are going to solve to get the value of x is e to the x plus 1 divided by e to the x equal to 3. Let us multiply every single term by e to the x. We have all of this multiplied by e to the x because I want to clear this fraction. E to the x times e to the x is e to the 2x plus the whole of this times e to the x is 1. This is equal to 3 e to the x. Let me bring everything to left hand side. We have e to the 2x minus 3 e to the x plus 1 equal to 0. This is another quadratic equation in terms of what? E to the x. But you should know that this is not factorable. Therefore, we are going to apply the general formula to solve this quadratic equation in terms of e to the x. So since the quadratic equation is in terms of e to the x, we have e to the x equal to minus b plus or minus into the square root of what? B squared minus 4ac divided by 2a. Let us declare our variables. You can see a is equal to 1, b equal to negative 3, and c equal to 1. So now let us substitute. We have e to the x equal to minus b. B is already negative here, so it becomes positive 3 plus or minus into the square root of b squared, which is negative 3 all squared, minus 4. A is 1, c is also 1. Divide by what? 2a, a is 1. This is equal to 3 plus or minus the square root of negative 3 squared is 9 minus 4 divided by what? 2, because 2 times 1 is 2. This is equal to 3 plus or minus into what? Square root of 5 divided by 2. This is e to the x. But remember that we are looking for x, not e to the x. And therefore, we are going to take natural log of both sides. You take natural log of e to the x equal to the natural log of the whole of this value, 3 plus or minus the square root of 5 divided by 2. From the left hand side, you're going to be left with only x, which is equal to the natural log of 3 plus or minus root 5 divided by 2. Why do I choose to go with the two values? Because both 3 plus root 5 divided by 2 and 3 minus root 5 divided by 2 are all positive numbers. And hence, this is the solution to this problem. Thank you for watching. Do share to your learning colleagues. And don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.